Hi there. In this video, we are going to look at two-way tables. So we're going to look at presenting data in two-way tables and how to interpret two-way tables when we are presented with them already completed. Okay. So we use two-way tables as a way to present data which is split into two different categories. So if you have data that encompasses two different categories, it is often easier to deal with if you place it into a two-way table. Let's have a look at an example. So here's an example of a two-way table which shows two bits of data, two different categories. It shows preferred games console. So at the top here we have PS3 and Xbox, and it also shows group of children, which is divided into boys and girls. So we have two different categories here, but it does allow us to place the data into a two-way table to get a better understanding of the data. A very common exam question is that you'll be asked to complete the two-way table when you're given a half-completed two-way table. So we need to go through and do some calculations, maybe some additions or subtracts, in order to fill in the missing boxes of the two-way table. Okay, so at first we're going to have a look at this box here. If we know that 18 boys preferred the PS4 and there was 39 boys in total represented in this data, to find how many boys like the Xbox, we need to do a little subtraction. 39 subtract 18. That's going to tell us that the missing value is 21. And look how the line now reads correct. If there was 18 boys here, added to 21 boys here, we have a total of 39 boys here. So the data is correct in this line. We're going to do the same for girls. If we know there's a total of 47 girls and 24 of them prefer the PS3, if we do a subtract, we should be able to find that the missing value, how many girls preferred the Xbox, was 23. Okay, so now we need to look at finding the total. How many people altogether, boys and girls, preferred the Xbox? So we don't know this value, but we do know that there was 21 boys and 23 girls. So we can use these two facts to create an addition, which will give us our total here. So we're going to add 21 and 23 together to tell us that the total amount of people, boys and girls, who preferred the Xbox was 44. So we're now missing the final total. The total that goes in here will be the complete total of everybody who was represented in the data. What we should find is that when we take the totals here of PS3 and Xbox and add them together, we get this value. But also, if we took these two values, added them together, we'd also get this final total. So we should know if our two-way table is correct, because this number will be the answer to these two added, but also these two added. So that's going to give us 86. And if we double check there, 42 add 44 gives us 86. So we've completed the two-way table. You may also get some interpreting questions. So you may get a question that follows this, such as, how many girls preferred the Xbox? So then you would need to look through your data, find the girls, and find Xbox, and then you can quite confidently say 23 girls preferred the Xbox. If the question was, how many people preferred the PS3? So this time we're not looking for boys or girls. I'm going to look in the total column. But I do want the PS3 column. So the question corresponds to this 42. That's how many people preferred the PS3. So you quite often get asked to interpret the two-way table following completing the table of values. Let's have a look at another example. We'll do this one a little bit quicker. So we've got a half completed two-way table. There's some data available and it shows lunch options for pupils in a school. So we've got two bits of data, two categories. We've got whether the students are in year 10 or 11, and we've also got whether they take a school lunch or they take a packed lunch. We're missing some values, so we're going to do some calculations to work out the missing values. To find the amount of year 10 students who took a school lunch, we're going to do a subtract here, telling me that 96 year 10s took a school lunch. For year 11's packed lunch, this time we're still going to do a subtract. 197 subtract 104 is going to give me this value here. 93 year 11s took a packed lunch. Now I need to find my total of year 10 students by adding 96 and 104. 200 students in year 10, and now I want my total, complete total for this bottom corner here, which will be the total of year 10 and 11s added together. It will also be the total of school lunches and packed lunches added together, and they will give me the same total. So my grand total being 418. Again, I could have went for an interpreting question. For example, what fraction of the school preferred a school lunch? So in the question, I'm asking for a fraction. 221 students preferred a school lunch, and it's out of 418. So I've given my answer as a fraction. 221 out of 418. If it was possible to simplify that fraction, we'd go ahead and simplify that down as we do when we're dealing with fractions. Example 3. It's another bit of data here. We're missing some values, and we want to know how many people got off at various stations. We don't know how many people got off, how many males got off at Crewe, but we do know there was 96 males altogether. So I'm going to subtract 31, subtract 27 from 96, and that's going to leave me with my value for how many males got off the train at Crewe. Okay, now if we look around the data, we've got a few options of where to go next. So you don't necessarily need to do them in the same order as me, but they do need to be completed. So we'll work out how many females got off at Nuneaton, and we can do that by looking at the Nuneaton total. 56 minus 31 is going to give me my answer here. For the Crewe total, we're going to do an addition. For females getting off at Preston, we're going to do a subtraction. And for grand total, we've got options of adding the male and female totals, or the Preston, Crewe and Nuneaton totals will give us the same value here. 195 people got off the train altogether. Okay, so now it's your time to have a go at a few questions. I've put a question on the screen here. At this point in the video, I remind you that you've got the ability to pause the video at any point. I would like you to copy out and complete the two-way table and answer the question which involves interpreting the data in that two-way table. Okay, if you would like to pause the video now, copy and complete question 1. Okay, welcome back. I'm going to talk you through my solution. So my answer looks like this. You can see we've worked out that the amount of pears that were sold in the afternoon was 12. We did 20 subtract 8. The amount of apples sold in the morning, 64 subtract 28. The amount of bananas sold in the afternoon, again we're doing a subtract, and then a few additions to give us our totals. 120 pieces of fruit sold throughout the day altogether. That is our grand total. Our question asks how many pieces of fruit were sold in the afternoon. So we're looking for the total of pears, apples and bananas all sold in the afternoon. So our total would be 59 pieces of fruit, which is shown by this value here. So 59 pieces sold in the afternoon. Okay, question 2. Okay, let's have a look at a second question. So this time I'll give you a two-way table. It's partially completed with data, and the data is divided into two categories: what students had for their main course for lunch and what they had for their dessert for lunch. Could you pause the video at this point? Could you copy and complete the two-way table and answer the interpreting question? Okay, welcome back. I'm just going to talk you through my solution. So your two-way table should look something like this. So we can work out the total of students who had rice pudding as their dessert as 83 by doing an addition of these three values. We can work out how many students had lasagna as their first course, as their main course, and apple pie as their dessert by taking 38 and 26 away from 83. We can do the same here for students who had cheese salad as their main course and apple pie as their dessert. We're doing a subtract from 59, taking away 18 and 15. And then we can go ahead and fill in the other missing values. 28 will help us find this value, which would help us find this value, which would then help us find our grand total. This is the amount of students who were surveyed altogether about their lunch choices, 245. The question says, how many pupils chose pizza and apple pie for lunch? So I would look across at pizza, which was their main course. I would look down at apple pie, which was their dessert, and I meet here at a value of 33. So that's telling me that 33 pupils, 33 students had pizza for main course, apple pie for dessert. So 33 pupils chose pizza and apple pie for lunch. Question 3. Again, there is some information on the screen. Could you take this time to pause the video, copy and complete the two-way table, and answer the interpreting question? Okay, welcome back. I'll talk you through my solution. So your two-way table should look something like this. Again, I'll just work through a few of the values. We can work out how many red squares there was in this box of shapes by subtracting 18 and 18 from a total of 52. I can work out how many yellow triangles there was in this box of shapes by subtracting 14 and 22 from 60. I can work out how many total squares there was altogether by adding together everything in my top line, and then I can work through filling in the other values. There is 220 shapes altogether in this box of shapes. The question asks, what fraction of shapes in the box are blue circles? So I'm just going to find the blue circles. So I come along at circles and down at blue to meet here. So this is my value. This is how many blue circles are in this box of shapes. However, the question asks for a fraction. So I'm just going to display that as a fraction out of the total shapes in the box, which would give me a fraction of 10 out of 220. And if possible, we would simplify that fraction, 1 over 22. Okay, let's have a go at question 4. So you can see the complexity of the two-way table is increased a little bit. We're getting a little bit more difficult, but the information is still split into two categories. We have preferred sport and we have school year. Okay, could you again pause the video at this point? Could you copy and complete the two-way table, and could you answer the interpreting question? Okay, welcome back. I'll talk you through my two-way table. Yours should look something like that. So we have 400 students taking part in this activity day altogether. We can work out how many year 7s preferred swimming by doing a subtraction from 80, taking away these three values from 80. 80 students in year 7 altogether. We can work out how many year 10 students like running, because there's 78 students in year 10. If we subtract these values, we'll be left with those who preferred running. We can then go ahead and work out the remaining missing values. With a two-way table as big as this, we may need to do it in a certain order before we can find the other values. However, you will be able to find them all, and they should look like my answer on the screen. What fraction of students chose cycling or tennis? So I'm not looking at the year group because the question asks for students. So I want the total of students who preferred cycling. So I'm looking at this value here of 72, and the total of students who preferred tennis. So I'm looking at this total here of 148. So this is my total amount of students who chose cycling or tennis. If I want to present that answer as a fraction out of 400, because remember 400 students took part in the activity day, the fraction of students who chose cycling or tennis would be 220 out of 400. These two combined give me 220, my numerator. And of course, if we can, we would simplify the fraction down 11 over 20. Okay, so that's a slightly more complex two-way table, but yours should look like the two-way table on the screen here. Okay, final question from me, and this time it's presented a little bit differently. So this time all I've give you is some okay, final question from me. This time it's presented differently. I haven't presented you with a two-way table or a semi-completed two-way table. I've just presented you with some information. I want you to take the information out of these sentences and place them into a full, completed two-way table. Could you pause the video now and have a go at creating a two-way table to display this data? Okay, welcome back. So I'll just show you my completed two-way table. Looks something like this. So we're giving information in the question. We're told that there's 40 people. We're told that 13 of the people are male. We're told that 10 females travel by train and that 8 males travel by car. If 40 people are at the meeting altogether, I know my grand total needs to be 40. If 13 people are male, that's also telling me that 27 must be female, because I know the total is 40. If 10 females travel by train, and I now know that my female total is 27, those that travel by car must be 17. Again, I'm just making sure these lines, rows and columns add up to each other. If 8 males travel by car, and there are 13 males altogether, then 5 males must travel by train, and then we can go ahead and work out the following totals as well. If you've been able to create this two-way table, and you were able to answer the previous 4 questions by copying and completing the two-way table, that is excellent. You've shown a good understanding of drawing and interpreting two-way tables.